Hello viewers, welcome to my channel Teaching Online Math. Follow through as I work out question 5 from a 2023 grade 12 internal math paper 2. So this question has got two parts, A and B. A is on algebra, B is on computers. So working out 5a, simplify 10p to the power 3 q to the power 4 over 8m to the power 4 n to the power 2 divided by 25p to the power 4 q to the power 3 over 4m to the power 4 n to the power 2. So for this first part, what we're just going to do is, first of all, change the operation from division to multiplication. Then this will affect this fraction, so we are going to reciprocate this fraction. The denominator will become the numerator will become the denominator. So for this first part, we're going to have the following. A, so we're going to have 10p to the power 3 q to the power 4 over 8m to the power 4 n to the power 2 multiplying. So on top, we're going to have 4m to the power 4 n to the power 2 over 25p to the power 4 q to the power 3. Then we simplify. So now simplifying, we're going to start with the numbers, then we'll go to the variables. So starting with numbers, 10 and 25. There's a number that can go into 10 and 25, which is just 5. So 5 into 10, that gives us a 2. And 5 into 25, here we get a 5. Then for 8 and 4, 4 can go into 4 once, so 1 here, and 4 into 8, here we get a 2. So if you've seen, there's a 2 here and a 2 here. So 2 will simplify 2 into 2, giving us 1 here, and 2 into 2 gives us 1 there. So for the numbers, we are remaining with 1 here, 1 there, 1, and a 5 here. So that's what we get. Then going to the variables, we can start with p to the power 3 and p to the power 4. So p to the power 3 can go into p to the power 3 and p to the power 4. So p to the power 3 into p to the power 3. This just basically gives us a 1 here. And then p to the power 3 into p to the power 4. So this will leave us with a p. So we just cancel out the power 4. Then this will also be the same for q. Okay, so q to the power 3 can go into q to the power 4. So q to the power 3 into q to the power 3, this basically just gives us 1. And then q to the power 3 into q to the power 4, here we just simplify the power 4, so leaving us with q. Then going to m, so the m's here will simplify, they've got the same power. So m to the power 4 into m to the power 4, here we get 1. Then m to the power 4 into m to the power 4, we also get 1 here. And then for n, that's the same situation. N to the power 2 into n to the power 2, we get 1. And then n to the power 2 into n to the power 2, we also get 1 here. So then, writing what we remained with, for this part, we have 1 times q. So this gives q over 1 times 1, which just basically gives us 1. Then times 1 times 1 times 1, here we get 1 over 5 times p times 1, we get 5p here. So then multiplying, on the numerator we're going to have q times 1, which will just gives us q over 1 times 5p, we get 5p. So this here is our answer, q over 5p for the first part. Answering the second part, the second question, study the following pseudo code. So the first thing is start, enter ES. If S is less than E, then display error message. Else, probability is equal to E divided by S. And if, display probability stop. Draw a corresponding flowchart for the pseudocode above. So for this code given, we are required to come up with a flowchart. Now, a flowchart is just a systematic way of showing the various steps that are used in doing a task. So now each step is written in a box, and we're going to have arrows. Okay, we're going to have arrows that are going to be used to join the boxes. So the first box that we're going to show for the first thing that has been written here, start, is the start box. So let's draw a start box. So we're looking at 5B. So our start box will just be an oval shape. So we're going to draw an oval shape. So we need to be very neat as we draw these boxes. So this here is our start box. So in the start box, we'll just write start. So this here is start. So then, following the code, the second thing that we need to come up with is an input stage, because they've said enter ES. So for this stage, we are going to draw a parallelogram. Now, here's how this shape will look like. So remember, between the boxes, we need to draw arrows. So I'll draw it like this. So first of all, I'll start with the arrow to connect this start box to the input stage. So now our input stage will have a parallelogram. So these sides are slanted like that. So this right here is our input stage. And then in the input stage, we just basically write what has been given on the code. Enter E, S. So enter E, S. So that's what we'll show in the input stage. The next stage, looking at the code given, if S is less than E, then. So what stage is this stage? So the next stage is just a decision stage. We are going to draw a diamond box. Okay, so the stage is known as a decision stage, and for this stage we are going to draw a diamond box, which is also just known as a decision box. Looking at what has been given, if S is less than E, so we're going to change that to is. So it is going to be is S less than E, and we're going to put a question mark. So now we are going to have two outcomes for this question, okay, which is just basically yes or no. Now this is because the word if from the code is a condition. So then the word then, okay, the word then specifies the outcome, that if the condition is satisfied, then we are going to have yes. Okay, so what I'm just basically saying here is that we are going to have a diamond box, which is the decision box, and then in the decision box we're going to have a question. So from if Okay, if you've seen here, we've been given if S is less than E. We are going to have a question, is S less than E, and a question mark. Then we are going to have two outcomes for this question, which is just basically yes or no. Now this is because the word if from the code is a condition. Okay, and then the word then, this word then specifies the outcome. Okay, if the condition is satisfied that S is less than E, so we're going to have the outcome for that condition. So if S is less than E, the outcome is that we are going to have a display of an error message. Okay, just from what we have here. So since the condition is satisfied, yes, S is less than E, then we are going to have a display of error message. So this is what we're going to have for this stage. So we're just going to draw the decision box. So our decision box will go like this. So in this decision box, we are going to have a question. If S is less than E, so from if we are going to have is. So we're going to ask a question, is S less than E? Then question mark. And then we talked about the outcome. That is if the situation is satisfied here, S is less than E. So we're going to have yes this side. So we show an arrow for this and then we indicate yes. Now what we're going to have is a display error message. So display error message is an output process. Okay, and an output process has got the same symbol as the input. So for this, we draw this box. And then the information that is going to be in this box is just what has been written here. So we are going to have a display error message. So for this part, we indicate the following. So we're going to have a display error message in that box. So that's an output. That's what we get if S is less than E. Then what follows after display error message is else. Probability is equal to E over S. Now the word else specifies the alternative outcome. Okay, so this outcome means no, S is not less than E. So we're not agreeing to the condition S is less than E. So we're saying S is not less than E. So this is the situation where the condition is not what met. Okay, S is not less than E. So for this one, we are going to proceed to calculating. Okay, this is because S is not less than E. In this case, S is supposed to be greater than E. Okay, in the calculation of probability, S is supposed to be greater than E. So for us to calculate probability, E is supposed to be less than S. So this gives us the processing stage. So the next stage is the action or processing stage, which is just shown by the use of a rectangle. So we're going to draw a rectangle for this stage, and we're just going to basically put the formula there for calculating probability. So for the arrow, we will show no here. This is because of else. Okay, else, and we're saying no to this question. Is S less than E? No. So for this, we proceed to calculating. So we're going to draw a rectangle. And in our rectangle, what we'll just basically have is probability is equal to E over S, or E divided by S. So we're not going to put the word else. Okay, so else interprets to no on the flowchart. So for this one, we just put the formula probability is equal to E over S. So now the program is going to end if we have a display of probability. So after calculating probability, we need the value of probability. So the program is going to end if we have a display of probability. So end if display probability. So the next stage is an output stage. So for this stage, we are just basically looking at this parallelogram. So that's what we're going to draw. So drawing an arrow first, then drawing the output box, so what we're going to have in this output box is a display probability. So that's what we're going to have in the output box, display probability. Then the last stage after display probability is the stop. So the last stage is the stop stage, and for this one, the stop stage is going to have the same box as the start stage. So we draw an oval shape after this stage. So this here is going to be our stop, and that means that the program has come to an end. So we started with the start, then enter ES, which is an input stage. Then we went to diamond, where we get the decision. Okay, so here we have a decision, and we ask a question here: is S less than E? So if yes, then we display error message. If no, then we proceed to calculating, because E is supposed to be less than S. Okay, so S, it can't be less than E when you're calculating probability. So probability is equal to E over S. So that is our processing stage. Then display probability, this here is an output, and then we stop. We can also have a connection from display here. We can draw an arrow from display to an arrow between display probability and stop. So we can also draw a loop from the output stage, which is this one, display error message, to the stop stage. Okay, so between the display probability and stop here, we can connect this. So this is because the program will stop if we get an error message here. Okay, so meaning we have to start again, enter correct values of E and S for us to proceed with our calculations. So this here is our flowchart for calculating probability. Alright, so that brings us to the end of this video. So thank you so much for watching this video.